I don't know that many of us really think about the clothes we wear as full of science, but you refer to clothing as technology. Can you explain that?
Yeah, clothing is an incredible technological platform that is attached to our bodies, and very few things are actually attached to our bodies for long periods of time. You wear clothes for several hours, so you can get a lot of information about the clothing, your environment, your body, but also from the outside where you are located. So maybe sensors to detect the quality of air, the amount of UV you are exposed to, the things that you're eating, how your body reacts, the sweat. Clothing, you can get the entire story of what happened on your entire day, because we can leave our home without a phone, yeah, but we cannot leave our home naked. That's, I can guarantee you that. Clothes will always be next to you.
So, in the future, and probably not so distant future, our jeans and t shirts might be wearable sensors that can tell us if we're having kidney failure, heart issues, etc.
That is actually a reality in many cases, especially for military applications and also for people in space, where you can monitor remotely how they are feeling, how they are reacting to different environments and conditions. We are a moving platform. Imagine we can detect, for example, pollution in one area or exposure to different chemicals and communicate that information.
As a chemical engineer, what brought you into this unique intersection of textiles and nanotechnology? Now, I hear superheroes might be involved.
Most of the superheroes, the power comes from clothing. Superman's cape that allows you to fly, to stop the bullet. Batman stops the fire. Aquaman can go into big depths in the ocean without changing the shape. Flash can go extremely fast with low friction between the air and the clothing. So I'm fascinated by these textile-enabled superpowers. Yeah, also fascinating because they were developed in the 1930s and 1940s when these materials did not exist. But somebody had the imagination that these materials maybe one day will exist. And that inspired a lot of chemists like me. Luckily, 40 years later, all these materials do exist. We use them every day. You see them in NASCAR clothing that prevents fire. You see with your firefighters in your neighborhood. In the Olympics with this fancy clothing that can make you very fast in the swimming pool. I'm fascinated by that transformation and the power that textiles as a platform can enable. Basically, make us all superheroes.
Do you have a separate favorite project or another favorite project you've worked on that merges science and design?
Yeah, so I'm very lucky because in my department we have fashion designers and we also have architects and painters. A few years ago, we worked with a student from Africa, and she was fascinated by some of the molecules that we were developing. And she wanted to use these molecules to develop a new mosquito bed net to kill mosquitoes for that transmit malaria. So we designed a molecule just for that, and then she designed an entire collection based on that molecule and in that particular technology. So what we do is we work with these molecules that are fascinating, are called metal organic frameworks. So basically it's like a cage. You imagine a cube, for example. All the points in the cube are actual metals and they are connected through an organic layer. So we made these layers to be attached to the cotton, and we grow the molecule from inside the cotton. So we use cotton as a platform to grow. Instead of attaching to, we grow like a building. So a building usually has a foundation, and then you make the building from the foundation up. We do the same atom by atom. So in that way, we can build the framework for our building, and then inside this framework, we have the insecticide, and this is the insecticide that will be released at the time that the mosquito is more active. So we basically calculate based on the amount of UV radiation when do you open or close. Yeah, so maybe the mosquito will come between 5 and 7. Probably this is the time we're gonna open. The other mosquito will come about 4 p.m. where lights. So we can actually tune that to the scheduling. Basically, we want to match the schedule of the mosquito. Yeah. So look into his calendar and match it with us. So that was a good example because it affected a real life problem, and the family of this person have experienced malaria. So it's not like an imaginary problem. The big complex problems cannot be solved only by scientists or only by designers. You have to work together because this is complex problems require complex solutions. And I love the way these ways of thinking are so complex and different that the solution is usually at the interface.
What would you want our viewers to leave knowing about your research?
I will say that everywhere you look at, you can see science, and you can see the power of ingenuity and the power of science. From the moment that you are sleeping on your pillow, those are texted out. When you brush your teeth, that's another fiber. You can get information from brushing your teeth, from the food that you eat that has fibers as well as cellulose, the clothes that you have every day, the napkins that you clean your mouth after you eating. All these fibers have an incredible amount of science. And if we look closely and deeply, we can see how we can use these items that we take for granted every day